Good day to you. This is Anagalactic bringing you another science presentation. In cosmic science, we're attempting to understand the universe. Always has been a top goal of humanity to have some conceptualization of the universe. Why would we want to conceive the universe? It's obvious that we can see it. It's all around us. Shouldn't we just accept it? Once again, bringing up the question of why do we do science? What is this thing called understanding we seem to cherish so highly? Our situation here with respect to the universe is that, first of all, of being human, second of all, of being earthbound, but then you look at the reciprocal side of that, everything else is non-human, and it's much larger. So the human situation fits into a larger picture. Well, that's called perspective. A perspective on the questions that we really have. And the questions we really have as humans have nothing to do with science, have nothing to do with logic. We're trapped on Earth, and we're trapped in these bodies, trapped with our emotions and trapped with each other. We can't get away from the situation into which we're born, which is hideous beyond belief. Absolutely crushing situation, producing wars and interminable sin, as the Bible puts it, is death, misery, injustice, and no answers to any questions that are of any meaning to humans. This results in all kinds of fabulous philosophies of how to get through this life without losing your mind. That devolves to a natural selection promoted goal, which is simply preserve your life at all costs. And that, of course, resulted in the first execution of a force between humans when Cain, one of the sons of Adam, killed his brother by applying force to him. It's not said how Cain slew his brother, but it is the first recorded act of murder, and that characterizes humanity. And nothing else even comes close to characterizing humanity other than murder. Born murderers. Not Abel. We don't know what he was, except that he was not the first one to think of murder. And what does this have to do with science? The origin of force is very mysterious in the universe. In fact, it's not addressed in any way by modern science, and yet the entire universe is force balanced and consists of nothing but force. That can be said. There are several ways of characterizing the universe, but the way man has learned about force, the application of force to the man's neck, or perhaps it was the application of force by hurling a rock at him, perhaps it was a sharp instrument. But mankind has never lost the knack of murder, and the application of physics is primarily in the construction of weapons to murder other humans. Bullets are the greatest, most powerful invention of man. Electricity doesn't even come close, unless you count the electric chair. After bullets, we learned how to fly, and one of my favorite writers, Robinson Jeffers, the poet laureate of North America, at least for the white people, Robinson Jeffers talked about the advent of air flight, one of the great goals of man, to release the joy of man's heart. And Robinson Jeffers observed that the purpose of air flight was to get above men's heads to drop lead and explosive devices down onto humans to murder as many of them as possible with one bomb. So projectiles are the first application of physics. This is why humans do science. It's to murder each other. And there is no argument against that. And that's final. And that's why the world is winding down very quickly now, as it winds up with technology, without any restraint on the use of force between humans. Ukraine is just a small whimper before the big explosion, and it's almost over. So why do we do science? Is it just to murder each other? No, there's something going on in the meantime, an entr'acte, you could say, in between the main shows of murder and more murder, just the former war and the next war, with all the current wars and injustice, torture, and madness that characterizes the human race. Where the hell does science fit into that, besides the construction of more mass weapons of destruction? What are we doing? Have you asked yourself that question? You're going to have to now. Because in order to understand the universe, you're going to have to understand you. Your place in it. What does it make any difference whatsoever what the universe is, when you can see perfectly well what it is for you? It's death. But you're alive right now. Now there's a curious situation. Some humans are actually alive at this moment, the eternal now, as they say in the Endless Philosophy Club. So you're here now. So what? Well, if you need to make a living, that's another use of science. It's not just for murdering each other. It's for getting jobs to murder each other. The Germans know all about that from World War II, but every country knows about it. And every state in this union knows. Science is for murder. And that's all your governments are capable of, is murder. Every government has an armed force. Even Switzerland, which is armed to the teeth and can cut itself off from Europe at any time. They have erected in Switzerland a giant moat, and they can cave in this moat, the snap of a finger, to cut themselves off from the rest of Europe. I wonder why Switzerland might want to do that. This Earth is a death trap, and all this stuff with Elon Musk flying us to Mars, you'd have to be a sissy to believe in that stuff. You'd have to lack any kind of maturity to credit the human race going to Mars for any reason. Elon Musk is psychotic, and so are the rest of our engineers and technological whiz kids. And they'll be just like the Germans at the end of the war, when it's pointed out to them what they were really doing. It's because you're stupid, and you've trained to be a monkey. You have to survive, and therefore murder is expedient. That's what was said of the murder of Yeshua. So murder is nothing new, either in the Bible or in common daily life. Everyone is being murdered all around you. You see hobos around you? Homeless people in America. Richest country that's ever been on the face of the earth. Just filled with homeless people like Calcutta now. Where does it end? Is it, in all the science fiction presentations, Star Trek to Star Wars, they never address the real question, do they? How do you stop humans from murdering each other? Well, you don't obviously do that. Nobody has been able to do that. It's impossible to control. So we have this madhouse being run by so-called scientists, and what's the pastime? How do you and I get along? Just hoi polloi, the usual slaves, the N-word. That's what everyone is who's not in politics. So what do you get out of it? What do I get out of it? You get entertainment from madmen, murderers. Passive murderers is the best a human can be. We'll never know if Abel would have turned out to be a murderer. One thing we do know, Yeshua was not a murderer. So we know of at least one man who made it through this. And the proof that he made it, he was abducted. Scotty up there in the engineering room just received the word, beam him up. And up went Yeshua in the sight of thousands of people. So if you believe that myth, and you might want to reconsider it if you don't already think of it as just pure shit, something that might offer hope. The scientists love it when you put down God. Well, today in our presentation of cutting-edge science, which I call the Fermi edge, the bubble edge of physics, We intend to get the answers. That's what science does. That's all we do. It has enormous repercussions when you use your head and turn on your mind and start to think instead of just react and feel, and use the other part of you that was given to you by heaven to think about heaven. If you don't know where you are, then that's how you'll end up. Now, the philosophers can always down a few and then just get right in our faces and say, well, you're going to die just like we're going to die. Yeah, but you're going to die without wisdom. And we intend to be at least ahead of you in that way. So it's a race, just as it says in the New Testament. It's a race and it's a war. Either you make it or you don't. Either you achieve wisdom or you don't. One problem with that is that as you achieve wisdom, or perhaps imagine you're achieving wisdom, which might not be able to tell the difference, once you get close to wisdom, you're going to notice a sea shift all around you, underneath you, and all the way through you, because you're close to the truth. And once you start getting close to the truth, you're going to get dizzy. It happens to all of us. Yeshua was tested this way. Satan, his sworn enemy on earth, tried to make Yeshua dizzy, brought him up to a pinnacle, one of the temptations. That was Satan talking to Yeshua. Again, a myth from the past, handed down to us by the Jews of all people, but that was their hero. Strange world we live in, isn't it? This thing about death and temptation and Satan, evil, sin, murder, an ejaculation of sheer horror and disbelief. Murder? That's one of the commandments, don't murder. Well, that's how you say the commandments. Break the Sabbath? You know what the Sabbath is? Just so you know, this is an astronomy channel. The Sabbath is about the moon. Did you know that? Only a Bible scholar would actually be interested in such. What the hell are you even talking about? The Bible, the commandments? Nobody knows what you're talking about in America, unless they're from the far right. In which case, yeah, they're murderers. So Protestants are just in on the murder game like everyone else. The Catholics used to have the market cornered. I mean, you know, the stock and security exchange might be after them for monopolizing an industry. Oh, the Catholics had cornered the murder industry in Europe for somewhere around 1,000 years. So the Catholics are in nobody's good favor, who knows anything about history, but the Protestants take the cake. The Catholics now are doing astronomy, they're doing science, they're rational, reasonable people. Roger Boschkovich was a Catholic. The greatest scientist who ever lived was a Catholic. As for getting to wisdom, well, as the good book says, where is wisdom to be found? Well, we know the answer. It's in heaven. That's where Yeshua went. That's where all the prophets are. Anybody who's religious, you should be looking at heaven exclusively. It's where your master is. It's where your God is. Your God certainly isn't here. But we know someone is here that's not God, but sure acts a lot like God. Well, that's the murderer. So you don't have to believe fables or fairy tales or religion or myths or anything, but unless you get that side somehow, the espionage side, what the hell is actually going on? Well, good luck finding an answer to that. Well, your good luck begins when you start to latch on to the ancient wisdom. The stuff that was recorded by those knucklehead primitives of the past. Any of them believable? Any of them reputable? Well, some of them wrote down stuff that no man could make up. Like the drowning of the entire face of the ecology with a worldwide flood. Well, isn't that just pathetic that any human being would believe that? Well, you can look it up in Wikipedia. Mega tsunamis buried the dinosaurs, which is the only logical, rational explanation, So lo and behold, the ancients weren't so stupid after all. Only the Bible records what was actually discovered by science in the 1980s, and it took a hell of a long time before even the son of a Nobel laureate. Luis Alvarez was a Nobel laureate in physics. His son Walter discovered the Chicxulub impactor. You know what that is? It's a comet that struck the Earth. It's still debated whether it was a comet or an asteroid. It's a bit difficult to tell. But it was enormous. Well over 10 kilometers in diameter, and it struck the Yucatan Peninsula, what now is the Yucatan Peninsula, and the entire Caribbean Sea is basically the leftover remains, uses of force, uses of physics. Even Galileo Galilei, when he got his telescope from the Netherlands, immediately went to the Navy to sell it so the Italian Navy could murder its enemies with the scientific discoveries being made for murder. And of course Galileo wasn't really into that, but what's Galileo into? The same thing Leonard Susskind is into, Larry Krauss, Neil deGrasse Tyson, and all the baby-faced wonders like Sean Carroll, and God, I can't even recite their names without becoming sick to my stomach. They're just pansies that work for the industry and lie in their teeth and don't even know it. I'm convinced they don't even know they're lying. They don't care. Well, hopefully you do care. You're actually out to get something out of science. Have you asked yourself what that is? You're going to have to now, because we're going to get the definition of the universe so that it can be conceptualized for whatever reason you might have. Maybe it's to murder your brothers. I have no control over that, but you're not going to make any weapons of mass destruction or mass weapons of destruction or whatever they're called. All of this is geometry so you can conceptualize the universe, so you can listen to the universe correctly on her terms, so you can get wisdom from your creator. Because without that, you're Cain, or Judas, or Trump, or just an asshole like Larry Krauss. You know, I'm actually subject to the judgment for calling any man worthless. Good thing I didn't do that. I never call any man worthless. But a statistical group that all behaves the same way, that would be modern astrophysics, yeah. What are these men supposed to be to us? The ones who interpret the universe to us. They're the priests. I'm a priest. So's Larry Krauss. Well, in Yeshua's day, he made it quite clear there's more than one kind of prophet. And Moses made that clear as well. There are prophets, and then there is another kind of prophet that observes the power that a prophet has. And oh my God, power is money. And of course, also, power is the ability to murder your brother. If you have power. And then there are the sheep, the N-word people. In America, they're all white. They're just happy-go-lucky gamblers. And they just live and die, and that's puppy love. You had your puppy cuddly time, and so you're sweeting off to the by and by. Whether you're an atheist or not, they all think the same way. They don't think at all. They don't have time to think because they're monkeys and they need to club the other apes to get those jobs before the other apes take all the money. And then you die of starvation. Oh, well, that's natural selection according to your priests. They're everywhere. It's not just in astrophysics that they're completely out of their minds deluded. It's also the earth sciences. Where are humans from? Isn't that a reasonable question? You know you're not allowed to even ask that question anymore. Well past 1984. If you've heard of George Orwell's book, believe it's George. I used to confuse him with Orson Welles, because Orson Welles gave the War of the Worlds broadcast, which set off a panic on the East Coast because they thought it really was an invasion from Mars. Oh, Orson Welles got into big trouble for that. But anyway, all over the place is just catastrophism, it's just Endsville. Is science is insane? And to begin today with our topic, we begin with one of those men, one of the top astrophysicists on the Earth today, is Martín López Corredora. I believe of España. He works for the La Canarias Observatory. Now, this is mostly dated information. The Big Bang has been discredited at the top, and only the hangers-on are still clinging to the Big Bang, in the same way that natural selectionists just pretend like nothing has happened as far as proof or disproof of their theory. So the charade continues, the industry continues its propaganda, and López Corredora, if I'm pronouncing his name right, Spanish, such a beautiful language, but I'm an American, I'm sorry, it's just the way I try to pronounce it, but I don't know if I am pronouncing it right. There's no way for an American to know that. You just make a noise and hope. López Corredora. Martín, if I'm pronouncing his first name right. Redshift, Expansion, and Controversies. This is by Martín. It was written quite a while ago. Does redshift mean expansion? Well, of course, the same way as humans are monkeys. Humans are monkeys, and by the same logic, redshift means expansion. Because you are told that that's what it is. You can't know they can't explain it to you. They can only shake their hands at you and get emotional like Larry Krauss. So López Corredora wrote a fantastic book by this name, which you can download for free. And it's well worth reading because it brings you up to speed on what actual physics knows. I don't know how he's tolerated. No, it's very difficult to be tolerated by the industry if you don't go along with the reigning paradigm, because that's how they get their money from the governments. Remember, I warned you, when you get to the edge, when you start to get your solutions, you're going to be in the hot seat because it's got to have something to do with humans. It's got to have something to do with humanity. Why are we doing this? Well, I've told you many times, but it does go to the other side of what it means to be a human. We are after something tangible. We being people who want wisdom. See, that is the goal. We take that for granted here. You want the knowledge of heaven because that's where wisdom is. We must consult the universe because we don't know where we're from. We don't know why we're here. Has anybody ever told you why the human race is on Earth? Need there be a reason? Well, now you're in the philosophy cafe again. No, it's outlined. You start with knowledge. Knowledge produces understanding. There's a Hebrew word for each one of these things. I did a 400-page study on this. I am a Bible scholar from the previous life. You only live twice. After understanding comes the spooky one, Chokmah. It's not bin, which is knowledge, and it's not even binah, which is understanding. It's what follows understanding. That's called wisdom. But where shall wisdom be found? The rhetorical question is asked. You find it in heaven. You have to interrogate the universe. In order to do that, you have to turn on the lights. You have to learn logic. You have to learn to think. Otherwise, you can't even ask a logical question. Well, science teaches you how to do that, but not to get answers from humans. If you want or think that you need answers from humans, there are plenty of churches. There's plenty of philosophy rooms. You can listen to guys like Lawrence Krauss, but you're getting it from humans. One of the reasons that I broadcast is to bring this whole dilemma into perspective. We get knowledge by measurements. We use a number system to assist us in measuring. Once we've done that, we have a heap of knowledge. For instance, light speed. It is the only precision number ever discovered. So now we've come full cycle with the numbers. That was the final summary in a months-long sequence on the nature of the number system that we use. Now we have two. The one that I discovered is the forerunner and generator of the number system currently in use in science called linear numbers. The linear number system is a fully defined system now. That was fully defined only in my lifetime by John Conway. The discoveries that he made, for which he should have gotten a Nobel Prize, but that's another story having to do with sin. So John does not get a Nobel Prize for his discovery, even though it's the solution to defining once and for all what is the number system we've been trying to use for 2,000 years. Well, now we know it's the derivative number system with respect to the number system that the universe uses. I discovered that number system in 2022, a two-component rational number system based on light speed. Max Planck is the one that threw in that it's that 2 times the reciprocal of 2 in energy units equals light speed. And so it's a direct relationship between energy manifestation in the universe and the propagation of light. And therefore light speed is the most critical number to understand. What is it? Technically, it has been fixed for all time. And this is actually a reasonable thing to do. That we've actually, for the first time in human history, fixed a physical number value. It's not irrational either. Although you could say so. But it's actually the ultimate calculus derivative that is so precise that nothing can be more precise than light speed. And what is it? It's the relationship between distance and time. It's distance over time, a two-component number, yes. So it is a spherical number. What does it represent? Well, in 4D hyperbolic space-time, it's depicted in a 4D projection down to 3D as a light cone. You could say it's a conic, except for the midpoint. A conic traditionally are the sections of a cone, where if you slice it straight across the cone, you get a circle. At an angle, it becomes an ellipse. So we have the hyperbolic range, the parabolic range, which is a mean between ellipse and hyperbola. The parabola is kind of like the curved straight line, in that it divides the hyperbolic curvature system from the elliptical system, which are the closed lines. But the nature of these spaces, which we call elliptical, hyperbolic, and parabolic, are all the same. They're curved space. And the hyperbola is a linearization, a partial linearization of a circle. An ellipse is a partial linearization of a circle. You take the circle and you squash it, squeeze it. That's a linearization. You can see it, where the midpoint splits to two midpoints. The same thing happens going to hyperbolic space from straight space. But everything relates to domains. One of them being straight, what we call linear, and the other one being everything else, because it's not straight. Well, the not straight ones we say fall into categories, and this has been very useful. Hyperbolic space is now the analog of spherical space, because really hyperbolic space is virtually inside-out space. It's used that way in space-time, but actually the inversion is due to the negativity of time. It has a negative valence with respect to space. So you have 3 plus for space component, linear components, and time has to be negative. Do you know why? It's so it can be imaginified. Because complex numbers are now considered to be the superset of all numbers. What's very interesting is if you go through that sequence as we did, starting with the complex numbers, and believe it or not, they're even considered to be hyper-complex, but we're talking about two-component numbers, which are really unique in the realm of number systems. The other ones are all one-component systems, but complex numbers are a two-component number system. That's powerful because it addresses circular space. Two-componency is required for circular space, x and y, so obviously two components, yes. Well, if you use a two-component number, you can add a circular function to linear space. That's why complex numbers are used exclusively in quantum mechanics and astrophysics. There are no other numbers. They only use complex numbers for that reason, because we're now forced to address curved space. Well, what if we had a number system for curved space? Well, complex numbers gave us a clue we could have such a thing. Well, I discovered the thing that is. Two-component rational numbers also add a circular component to linear space. But instead of adding it to linear space to create basically a special algebra to get its circularity, instead you object-orient it into an object, which turns out to be the circle, which turns out to be virtually the sphere. The circle and the sphere are extremely closely related. One might say eerily so. Because when the circle is given a value of 1, that is the circumference, is given a value of 1, something nobody's ever even thought of apparently, is just to say that the circle is 1. Well, there are reasons why nobody's ever said that. Because you don't have sine and cosine, you can't get the linear numbers out of it, so you have a circular 1. So what? You can't do anything with it. Well, you can if you use harmonic numbers, which all multiply to 1, which means that all the numbers in the system multiply to the system object. That's how it is in linear space. All the numbers on the line add to 0. There's a smallest number in physical space called a Planck unit of linear separation. It has a specific distance of 10 to the negative 34th power because there's no wavelength smaller than that. Well, that's why with Planck units you always see it over 2. Because the wavelength is measured on half of a wavelength, basically. Because you can do it either way, it's just a matter of choice. Because it is a harmonic relation, you could be either one. It goes up and down, but it goes down the same way it goes up. There's the same thing with the circle. You get pi for half the circumference. That's what the Greeks gave us, because they only used the upper half because it's easier, because its y is positive. Then you just reflect and you have the whole thing. Well, you don't want to cut it in half. Well, they did. So we got pi. Now the tau people are up in arms, and rightly so. We should be using tau. We're in the modern age. A number on the circle is always got to be represented with 2 linear numbers. Not with complex numbers. You have one number, but then you have to invent the algebra to get I back out. That's called conjugate algebra. When you have a circular function you never had before, that's a major breakthrough. That's why we use complex numbers. Well, what if you could do that without the imaginary component? You don't have to have an imaginary component on the y-axis. Combine them and see if it makes the object. That's called object-oriented programming. That was used in geometric algebra to remove complex numbers from the system. And it's still known. You could use geometric algebra. It's being used in robotics. And what is it? It's the creation of a planar object with a 2-component definition. Basically the inner product and the outer product. This goes very deep, and this goes to the methodology by which we can recompose our mathematical system so as to obviate the use of calculus. It's not just complex numbers that we can get rid of. We could also get rid of sine and cosine if we combine them into one number and make an object out of it. That's called the circle. But we don't have a two-component circle. We have not object-oriented sine and cosine so as to have circular numbers. Well, here at Anagalactic, we went one step further. We went right back to the Euclidean basis of geometry to see if perhaps we could find out anything about how we began, which was with the straight line. When you start with a straight line, all the numbers add to 0. Well, that's profound. Even the two infinities add to 0. Negative infinity and positive infinity add to 0. Notice the direction. It's 180-degree valence on a line. What does that look like in real space? Well, gravity tells us it's all of the lines. Instead of having 0 at the center of the line, you have a center to all the lines that go through it. There's actually a term for that in upper echelon mathematical geometry, but we don't need fancy-dancy terms. It's just what I call the radial line, which is all the lines either coming in from outside to reach the center, that's gravity, or going out from the center, which is the propagation of light. And that's where we begin today. The two methods by which we have to interrogate the universe so as to get the wisdom from heaven, which apparently is the last place anyone ever looks for it. We're going to need to use the tools that nature has given us to analyze our surroundings, our universe, which are a pulling in force called gravity along the radial line towards the imaginary centers. We proved it is imaginary. Nothing ever gets to the center in gravity. There is no mathematical center of gravity. There is a geometric center of gravity, but it's not linear 0. That was proved at A&E in 2022, and I just covered it again for about the 6th or 7th time in my last 3 lectures, if you'd like a recap of why 0 is an imaginary number. It's because it's a linear number. The center of spherical space cannot possibly be 0 because 0 is the additive identity. The reason all the numbers on the number line add to 0 is because 0 is the imaginary center of the line. And that's been proved, so you can accept that. Now we're going to go on. We need to understand light speed now, because in some ways it's the opposite of gravity. Light speed represents a force. Have you ever thought about that? What makes light have pressure? You know that you can build a sail, and there are diagrams of this that have been patented or in the United States Patent Office for light sails, and they're being engineered now, light sails, where you unfurl your sail, maybe around the moon. You construct this craft, you unfurl the light sail, and the pressure of light from the sun strikes the sail, billows it out, fills it. You can picture an aluminum foil, something like that for this, and pushes the craft. Very good, although slow to begin, as with any engine. It would have an infinitesimal pressure, which would then increase, called acceleration, due to the pressure of light. What in the world is that? We can conceptualize it, I think you can, that light acting as a wave would have a pressure. That's a force. Well, that is a manifestation of energy, but it's a manifestation of energy that has a direct effect on motion of a mass object like a wind sail attached to a craft. It's the solar wind, but it's the pressure of light. It's not so much the pressure of the ions. The sun blasts out a lot of stuff, but what's being used is the radiation, the EMR, the light pressure, the pressure of light. Albert Einstein quantized the pressure of light so that it could be considered as a particle, because a quantum of energy has to be a particle. It's the only way we can measure it is as its manifestation as a particle. That's called the photoelectric effect. Well, a light sail doesn't use the photoelectric effect exactly. What it uses is the elasticity of the inner bound of the universe in physical space, such that when the light hits mass, it transfers momentum. The light somehow passes its momentum, so light has momentum. That's the speed of light. It measures the momentum of light through space. It has momentum. That's energy, is momentum. It's not space. It's energy passing through space. And we can measure that as momentum, and that is the speed of light. It's its momentum quantum. The quantum of momentum is expressed as a photon in flight through free space. Now, does it travel as a particle? That question cannot be answered. It is an illegitimate question because you began with linear logic. And with linear logic, you can't formulate an intelligent question. You have to switch logic system. This goes by many names. I would say historically, imaginary space has been tried, but what we've been able to discern thus far in this transfer of momentum from something having momentum, in this case light has momentum, it contacts mass, right? And pushes it, so it has a force. Well, where did that force come from? What is the momentum of light? What generates the moment? Why does it go at that speed and no other? Very basic question. We've measured it exactly. It's 299,792.458 kilometers per second. Also, this has been said, 299 million. Well, once you're so close to 300 million, we actually could do this. We could say that it's exactly 300 million meters per second. We do not do so because we've already defined the second as the fraction of a solar year. And we don't want to lose that. We find that very useful on Earth. But you as a physicist must realize that the number 299,792,458 meters per second is based on an arbitrary definition of the second. That has been officially changed so as to do an inverse definition. And now we have the exact definition of a second. But do we? Do we have the exact definition of either one? We do not. What we do have is the dimensionless relationship between the two, which is 300 million to 1. In our conventional choice of the time unit, which we have conventionalized to 1 second, which is about that long, and our metric for space, which we've settled on the meter. Both of those are completely arbitrary, but when they're put together, they're precise. The relationship is precise. Whatever you choose for your time unit, it's going to have a fixed relationship with space called the speed of light. And you can measure it any way you want. For instance, if you measure it on an index of 1, now you have to define what that 1 is. Is it 1 meter or 1 kilometer? Because that will affect the balance. So if it's a meter, and you compare it with a second, which is this long, to a meter, which is this long, those two will have a relationship. But have you really defined what time is? Or what space is? No, but you've defined a relationship between the two. And now you need to choose your metric. How can you measure that in dimensionless units? What is the absolute relationship between light speed and its two components? In other words, what's the relationship between time and space? Well, a lot of space in a little amount of time is how we feel. We feel that it's a large amount of space in a very short amount of time. And that's overwhelming. It was so overwhelming that Newton could not handle it. He could not account for time lag, although he did talk about it quite openly. And I've expressed some unhappiness with Sir Isaac Newton in the past in some of my lectures. I make fun of anything I think needs making fun of. And if it includes the personality of the scientist, well, too bad for the scientist. But if I were in the presence of Sir Isaac Newton, I would not be putting him down. No. But here I have to really congratulate him and eat my humble pie, because Sir Isaac Newton had a lot going for him, and one of them was honesty. I can find, and that's really the touchstone. I mean, when I get less emotional about it, my human reaction to his irascible nature. Well, that's just the way it goes. He's a human just as I am. Well, I'm irascible too. And so what? All we want is the truth. So what he talked about with the truth of his mechanics for gravity, and he had mechanics for light too. He talked about the time lag. He couldn't figure out exactly if light took a lot or a little time to travel. It just looks instantaneous, but he suspected that maybe it wasn't instantaneous. Nobody could measure it really clearly at that time if it was instantaneous or not. Although actually there are ways of deducing that it's more likely that it takes time to travel. And that really wasn't finally visibly, palpably provable until we noted light aberration. Light aberration is a very strange term for something very simple, which is that when you look at a star from one position in our motion as the Earth around the sun, we take a look at a star from over here and then wait 6 months and take a look at a star from over there. Well, there's such a thing as parallax. That's not what aberration is, though. Aberration is when you're on this side of the sun, you're traveling away from the star, but when you're on this side of the sun and you take a reading on the star, you're traveling toward the star. And the difference in velocity, which is really 2 times the velocity of the orbital rate of the Earth around the sun, you're going away from the star when you take this reading, and you're going toward the star when you take the other reading, and they're not exactly the same for that reason. Because now you have to, it's a very, very tiny amount, as you can imagine, but because the Earth is scooting away, there's a redshift. And over here, well, it's a time shift. Which has to do with relativity. So that's aberration. The point being that it takes light a certain amount of time to travel. Well, that is called light speed. And light speed, as I've said, has been fixed for all time because nobody's ever going to discover anything that's going to change it measurably. We know exactly how fast it travels, given the fact And this gets a little philosophical given the assumed fact that we know exactly what is a second. Well, actually, that's impossible because it's based on a circular function. So we know approximately how long a second is, and we know approximately how long is a meter. There are quantum limits to measuring either one, but you can cancel them. That whatever is the infinitesimal in getting the exact number for a second is going to have to be related to distance. So you do your best to get an exact number for distance, but each one is going to have an infinitesimal fudge factor because you're trying to compute something you can never get exact due to a quantum limit. That's well known. It's really Heisenberg's uncertainty principle, but it really gets down to that immeasurable. What is that immeasurability? What is it exactly? Well, the calculus teaches us, although it's not really taught that way. The calculus teaches us what we can't do. If you get down and try to measure what is a circle, well, finally you have to admit that you can't. Because the two numbers that you get that are linear numbers, to get the vertical rate as it's deviating with a perpendicular force, so it goes in an orbit, well, where those two meet at a right angle, unfortunately, is linear zero. And nothing in the universe meets at that right angle. Where two forces meet, only Roger Boschkovich was able to compute what happens in the transfer of momentum. This would be, for instance, the pressure of light. When it causes the light sail to billow and be pushed by the force of electromagnetic radiation due to its angular momentum. It has had angular momentum applied to it so that the photon goes out from its source in the atom which spawned it from the electronic shell. It comes out from that shell and goes at a fixed rate through the universe. Why? That has to be from an impetal force. Something gave it that speed. What is that speed? It's the speed of something that has no weight. A photon is said to have no mass. Let me tell you something about that. The reason the photon is said to have no mass is that it's in free fall. That's the direct deduction of relativity, is that you cannot tell the difference between gravity, which is a centripetal force pulling in. You can't tell the difference between that and momentum, which in this case would be acceleration, because it is a force that's keeping the planet going in a circle. It has a linear component, which is its linear velocity. It's traveling at that rate. And that rate does not change when it curves. It has the same linear rate. So it's kind of magical that this planet, for instance, here's the star and here's the planet. The planet has a linear momentum that does not change as it curves. It's still the same linear momentum going in its path, which is either clockwise or counterclockwise, but it's one of those two. And on that path, it has the same linear momentum. And therefore, Newton interpreted the deviation from linearity as acceleration. And acceleration is due to a force. And that's why gravity is called a force. But that's a very strange force that pulls in spherically. It pulls space in spherically. To say that it pulls space in, I believe that we're now comfortable with that. I think as a group, just hoi polloi, you and I just trying to fathom this shit, it kind of makes sense that space could curve. But kind of makes sense. What's really happening is a force relationship being exhibited in perfect equilibrium is this linear force, which was the original impetal force of the planet. Has that force, where does it come from? Well, you'd have to say that it comes from the origination of force in the universe. Wherever that comes from, that is something the Big Bang has never dealt with. Whence originates original force? What causes the original force that leads to the force balance we see now? And can that be understood? Rudyard Joseph Boschkovich figured it out. The force curve for universal space on the transfer of momentum for anything. He didn't deal directly with light. To the best of my knowledge, he was dealing with what would be called palpable reality, mass, which everyone was interested in, of course, in the 17th and 18th centuries in which he lived. Force mechanics really wasn't interested in the photon. That came later. People were interested in it, but what could you do without being able to measure the speed of light? Nobody really knew what light was. Light was the last phenomenon to be probed successfully enough. We need a more successful probe to really understand light propagation, because somebody, somehow, somewhere, someday has to explain precisely why it has that speed and no other. Why is it 300,000 kilometers per second and not less or more? This is very strongly vocalized in philosophical circles in science, but nobody has been able to get too close to why light goes at that speed. That needs to be explained. That's our next task. Now that we've gotten the rationalization of infinity, so we now have rational spherical space, which we can project down to circular space easily enough, certainly in the static form. The geometry of the circle is now easy to understand, although without the metric, it doesn't really mean anything. It's beautiful. Spherical geometry is quite rational and beautiful, but it's not useful in the same sense as linear algebra is yet. I know that it will be, and you and I are going to see how far we can go before the explosion and the flood of everyone on Earth is going to want to do this pretty soon. It may not be pretty soon, but I like to think in cosmic scale, it's inevitable that spherical geometry will become the dominant mathematics. Probably not in this Earth age. I don't really think there's any chance or hope of this ever being recognized outside of a small circle of people who might be interested in this for their own reason. My own reason, I hide not. It's to get the wisdom that I need from the only source that I can trust, that I already know will tell me if I do the right steps. It's up to me, but the answers are there to be found. That is the legacy of science, and that's 1 hour and 10 minutes. In the next lecture, which I believe will be today, I'm feeling pretty chipper. Yeah. This is a little hard time for 68-year-old man with asthma. This summer was brutal. It still is, but it's abating somewhat. The fluff and dander of the Central Valley, this most hideous place on Earth for someone with asthma or for an astronomer. But I do have a refractor telescope that's capable of penetrating even civil skies. And the season of astronomy is upon us for those of us who don't like to shiver. Well, now's the time to do some astronomy. And we have a new moon coming up in just a little over a week. It's currently August 4th. We'll be back with you today, I pray, with our fuller discussion of light speed. Why does it have that speed? And why does light represent a force? What direction is that force going? I know the answer, so let me give you a teaser, and so maybe you'll be motivated to tune in for the next lecture, which could change your life. Any one of my lectures at any time could change your life, so that you will be able to get the answers that you need, which only you will understand your answers, but the steps toward wisdom can be learned. After that, it's up to you. So here's the teaser. If you had to summarize the forces of the universe into as few as possible, what would be your list of forces? Well, I think a physicist, especially of the mechanical stripe, would probably have pages of forces, since many are well known, some of them with very long names named after 1, 2, 3 to 5 men, in science's inimitable naming convention, naming things after humans. Oh, that's a big help. So, what are the basic forces? Well, what is a force? A force is something which applies momentum to a physical body, such that it can be measured. You usually think of that as linear force. For every action, there's an equal and opposite reaction. If here's a wall, and here comes a car, and it hits the wall has to give, but so does the car. So it has a forward momentum, it hits the wall, and there is an equal and opposite reaction which rebounds so that the car crinkles. That's action and reaction. That is a universal principle which was extended to a symmetry by Emmy Noether, who knew Einstein very well, and Einstein thought the world of Emmy Noether. So did the Nobel Prize Committee. She was only the second woman to receive the Nobel Prize in Physics. Madame Curie was the first. So, getting back to the forces, is gravity a force? We have determined that it is, since it applies a pressure that can be measured. It keeps your feet on the ground. That is a force, pulling you in. That's called a centripetal force. According to Emmy Noether, and indeed according to Newton, and to common sense, which is easy to say now that we actually do know, there has to be an equal and opposite reaction to centripetal force somewhere in the universe. Where is it? Is there anything going out? Not that we can see, unless, oh dear, there is one force going out, light. Light is a force that goes out from the center. Gravity is a force that goes in toward the center. Those are the only two forces, and they're in exact balance. Centripetal and centrifugal force are both measured in angular momentum because everything is spherical. So there's a spin that goes in called gravity, and it's a spin going in to a center where it's equalized. How is that force equalized? That is a deep question that has a very simple answer that I'm going to give you. The force going in is balanced by the force going out. What is that? You could say it in any number of combinations. As space is pulled in, time is pushed out. That is what I'm going to teach you, is exactly the right answer. And they're orthogonal in spherical space. Albert Einstein proved that. We're going to mathematize it. We're going to make it directly computable in object-oriented programming. This will give us the metric of space-time. It's time-space separation. The part that's going to blow your mind, as it will anybody who does get this, is that the orthogonality is between space and something that we cannot conceptualize while we're conceiving space. Because no man can split his mind this way. But what you can do is flicker. You look at it as space, and you figure out what time is from that. And then you have half the answer, which makes no sense. But it's tantalizing. There is a relationship between time and space that's geometric. But to get at it, you need a two-component number system where one component is space, the other one is time. What you don't want is to split space into three and make time imaginary negative. That's the Einstein field equation, which technically is psychotic. Because it can't be understood. It's just too much. It's not, there's no Occam's razor there. The Occam's razor comes with spherical numbers. But in order to compute it, you have to know exactly what those two numbers are. And they have a specific relationship to each other called light speed. But that light speed is related to gravity. Because if you think about the masslessness of a photon, why is it said to be massless if it has a pressure? It's because its mass converted to energy, which is no longer spatial. It's not in the spatial domain. It's in the time domain. But light somehow is both. Light somehow is both. What we need to come to grips with is how that mystery is related to gravity, because they're the only two opposite forces known. Centripetal force is gravity. The proton manifests it, and we now know that the proton, even though we conceive a plus-minus charge for the relationship between the proton and the electron, actually, that is gravity. It's gravity at the smallest scale that's holding the electron system to the protonic core. And it manifests as a spherical geometry. The same basic spherical geometry we see in macroscale structure, which we call gravity, is just the integral of protonic centripetal force. In other words, the proton bends space. What about the electron? The electron bends time. And the relationship between those two is not linear. It's not plus minus. It's spherical plus minus, which is in and out. Those are the two directions in spherical space. It's either centrifugal force, which is the radial force from the center, or it's centripetal force, which pulls in. One strange thing about centrifugal force is if you conceive of the sphere, a spherical system rotating, actually centrifugal force as we see it in planetary flight is linearized to a circle, which needs some explanation, because gravity does not seem to know about this circularity. Things should be just going around the sun in any direction. Like, that's how electrons behave, essentially. They go into spherical orbit, so it manifests a spherical arrangement. Planetary systems don't do that. They make a disk. That's been explained according to the known properties of spherical rotation. But here, when we're talking about spin, that is rotation, ultimate rotation, there are only two directions. In, centripetal force spins in. But the propagation of light spins out. It goes out from whatever center generated it. And it goes out from the protonic center, essentially. It goes away from what had been binding it. But it's obviously free flight. In other words, the energy packet detaches, and as soon as it detaches, it goes into free flight. What's causing it to go in a free flight? It's angular momentum of the universe. It's the angular momentum of the universe that takes the place of the expansion of the universe. That's why the universe is not expanding. It's because it's rotating. It's centrifugal force. And that satisfies Emmy Noether's symmetry of conserved forces. Angular momentum is a conserved force. Now you know it's the primary conserved force. That's why the universe is coherent and balanced on an energy balance. It's a force balance of in-spin, which is gravity, and outspin, which is light. We'll be back. I hope that gives you some food for thought. We'll have the mathematics to support it. And most importantly, the geometry to visualize it. Although, as you might well imagine at this point, it's going to rip it's going to rip your mind in half. That's why it's so important to have the geometry first. So you'll have a place for each paradox. There are 2 paradoxes that can be solved at once, exactly as we did for the 2 infinities, the one at the center and the one at the edge. The 2 forces, the one going in and the one going out, are absolutely balanced. And that's gravity and light speed. The 2 probes that we have for interrogating the universe to get wisdom from the universe on her terms. That's called wisdom in science. So I hope you tune in for the next few lectures. It'll be intense. I trust it'll be worth it. It certainly was for me. Stay tuned to Anagalactic with the secrets of the universe. Keep looking up. Once you do that, you'll see. You'll see. It gets spooky, but that's really what it is. You'll finally see the way you know you can. So stay tuned. Keep looking.